We're going to look at what happens when you start taking the limit way out at infinity, so you want the x value to be infinity. Today, y value is infinity or negative infinity. Tomorrow, x value is infinity or negative infinity off on the two ends. So this is pretty straightforward, easily covered. So we're going to go through this quickly because we've been doing this already. Yeah, sketch a vertical. Oh, we do have to remember or talk about vertical asymptotes, right? I'm assuming you're all good with them, but you know what happens when you assume things. This is a big one. Don't get tricked into infinite limits when you can just plug and chug. And yeah, we're still covering infinite limits. Okay, here we go. So we've got a function 3 divided by x minus 2. First of all, let's talk about some pre-calc stuff. The denominator will determine the asymptote. So if you have a term in the denominator, one of two things happens. It cancels with something in the numerator and gives you a whole, or it stays there, and that determines where the vertical asymptote is. You all knew that though, right? The vertical asymptotes are determined by what makes the denominator 0. Should I say it slower?
In Spanish.
Ich habe eine Function mit der Denominator und then, I can't do it. I don't know German. I don't know math German. Whatever makes the denominator 0 is an asymptote.
Oh, okay. Got it.
That's different than I was. Okay, never mind. We'll just-
It's not.
Everybody else good to go? Okay, so in this simple function, we're going to have an asymptote at 2. Then, what you have to figure out is what happens around the asymptote. Does the left side shoot downward and the right side shoot up? Does the left side shoot up, the right side shoot down? Do they both go up or do they both go down? Okay, so we'll be talking about that a little bit. Ideally, what we'd like to be able to do is determine that without doing way too much work. Okay. So, let's look at that function. Where's the asymptote? I changed the function, yeah. Asymptote's at 1, and therefore, we need to figure out what's happening on both sides of the asymptote, because that will allow us to figure out then what's the limit as you approach 1 from the negative, what's the limit as you approach 1 from the positive, and what's the limit at 1 if there is. Okay? Any ideas? How can I, because we know one thing, it's an asymptote. On the left-hand side, it's either going to shoot up or shoot down. How do I figure out which one it is? Mark, what would you suggest? Big honking number? That'll work tomorrow, but not today. Correct?
Something close to the asymptote.
There you go, something close to the asymptote. How close?
As close as you can get.
Mine, you're pretty close.
As close as you want.
Better way to phrase that. Good. What do you suggest? You want to do the left or the right first?
Right.
Okay, let's go, because that's easier.
2.
2?
Plug in
2.
2. Yeah.
Okay. So what happens when you plug in 2?
It's just 1.
Which means
Then it goes up.
that it goes up. Okay, so I'm gonna suggest a different approach. Number 1, 2 is way too far away from the asymptote because we deal with small distances. I understand you wanted something easy to handle. Okay. I want something really, really close. So he wants to talk about the right-hand side. The point being, we need a number bigger than 1. So let's take something like 1.00001. Okay. Really small value just to the right of the asymptote. I only need to know one thing. Is that answer positive or negative? I don't care how big the value is. I just want to know if the answer is positive or negative. So if I put in I forget how many zeros I said, 1.0001, will this be positive or negative? Positive. Therefore, will the whole function be positive or negative? Positive, so it goes up to infinity. Okay? And let's talk about that infinity thing. As the number gets closer to 1, so now I do 1.10 zeros 1, that denominator is going to get smaller. As the denominator in a fraction gets smaller, the fraction gets bigger. Okay, so is everybody with me on that one? Okay, good. Let's take a number to the left of 1, like 0.999999. If I put 0.99999 into that function, will it be positive or negative? Positive, because it's squared. So therefore the left-hand side goes up also. And so our function is going to look like that. Everybody with me on that? Okay. So again, technically we're plugging in numbers, but we're not actually calculating the numbers. You should be able to do this without a calculator. Okay. Have you heard the term multiplicity before?
Yeah.
Can somebody explain multiplicity? So I don't have to. You just heard it, you don't know what it is. I understand, like quantum mechanics. Okay. Multiplicity is the power that your denominator terms are raised to. It will help you determine what the function looks like without plugging and chugging. If the power on a term is odd, it's going to be opposites. One's going to go up, one's going to go down, or one's going to go down and one's going to go up. What you're used to around asymptote, the stereotypical value. If the power on the term in the denominator is even, they're both going to go up or both going to go down. So I knew going into this that my function will go up on both sides of the asymptote or down on both sides of the asymptote using the multiplicity. So just a trick to make your life a little bit easier if you remember it. Okay. And this confirms what we figured out. There's the actual picture of the graph. Both sides shoot up along the asymptote. The thing to remember, however, is when you're doing this positive and negative thing near the asymptote, you want to look at the value of the entire function. So if I put a -1 up on top here in the numerator, it would all of a sudden take this function and flip it over. Because we would have a negative value, which means the values get closer and closer to negative infinity. Okay, does all this make sense? What we want to avoid is putting in a number and calculating what 0.99999 minus 1 squared 1 over that value is equal to. I don't care what the value is, I care about the sign. Question?
Sorry, which one makes it both go up or both go down?
This too.
So if it's an odd number, then they go
Correct.
opposite.
Correct.
Then how do you know if they both go, like instead of them both going down?
Then that's going to be determined by figuring out if the function is positive or negative around the asymptote. Now you got to do a little bit of work for it. Any other questions before we move on? Okay, that's pretty much the gist of what we're going to talk about. Here's another one. Asymptote is 1. Multiplicity is 1. So it's either going to go up on the left, down on the right, or down on the left, up on the right. So let's put in, for simplistic sake, we can just put in 1.1. If I put in 1.1, is the function positive or negative? Negative, which means that on the right-hand side, it's going to go down. And now we're finished, because I know if it goes down on the right, it's got to go up on the left. So it's going to look like this. Okay? So don't make it more difficult than it has to be. Don't start getting out your calculators and figuring out, what 0.9999 minus 1, negative 1, all that other garbage. Just find the sign and use the multiplicity, and it becomes really simple. Eventually, we're building towards this big picture where we're going to use all this pre-calc stuff that you did last year and calculus to get really accurate pictures of graphs. So you remember when you did graphing last year, there were certain things when you were graphing that you might not have known how big that mound in the graph was. So you either plugged in points or you just kind of ballparked it. And calculus will be able to figure that out using a whole bunch of different stuff. So this is step 1, is how to deal with asymptotes. Also helps us deal with limits now. So notice, if I asked you for the limit of f of x as x approaches 1 from the negative, what's the answer? Shall I say it again? What's the limit of f of x as x approaches 1 from the negative?
Positive.
Infinity, good. What's the limit as you, okay, so I'm approaching from the negative. Where's this going? Up to infinity. What if I approach from the right? Infinity. What's the limit at 1?
Doesn't exist.
So now we can get into that argument. One side of the camp would say does not exist, which would be a perfectly acceptable answer. The other side would say infinity because the left-hand limit matches the right-hand limit. Okay. You don't get asked that type of question very often, but it is possible that you could give either one of the answers there. I think you'd get credit for both. This one, however, changes. What's the limit as you approach from the left? Infinity from the right? At the point? Does not exist. That's gotta be does not exist, because infinity and negative infinity are not the same. Okay, so blah, 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 did all that, yeah, good, good, yep. So more of what we already covered. Yeah, beating a dead horse, vertical asymptotes we talked about. There's the fancy definitions for vertical asymptotes, but you can all find one, right? Good, if you want to write that down, it's in your book. Where's vertical asymptote? -1, good. Where's vertical asymptote?
There's two.
There's 2. Where are they?
1 negative
1 and -1. Okay, factor that denominator into x plus 1, x minus 1, which both have a multiplicity of 1, right? Because you're looking at the value of the exponent on each individual term. So as a quick demo here, if I had a weird function like, nope, come on, there we go. If I had a weird function like 2x over x plus 1 squared times x minus 3. 2 asymptotes, where are they? -1 and 3. So tell me about the behavior around -1. One goes up, one goes down, both go up, both go down. What do you think it is? Both go up or both go down. We would find that out later. What about at 3? Yeah, so they go opposites. And again, that's determined by the value of the exponent on each of those, whether they're odd or even. Are we good on that? Good. Hopefully you covered that last year. Oh, I forgot cotangent. What about cotangent? Where are the asymptotes? It's tangent.
Oh.
Somebody said it.
0.
0, pi, 2 pi, blah, 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 blah. And then the trig functions get a little bit weird because the multiplicity doesn't necessarily apply. You have to remember what the cotangent graph looks like. The cotangent graph, it goes opposites, goes up on the right, down on the left. Okay? Beautiful. We're all done. So that ends.